All right, hello everybody. So I'm just going to do a quick video going over one of the problems from the worksheet that you should have done yesterday. So this is kind of just another extension on to 7.4. So the problem I'm going to do is the second one. It is right up here in this corner. We're again solving this through Gaussian elimination using a matrix. So the first thing I'm going to do is extract this and make this into an augmented matrix. So doing that, I'm just taking all the coefficients and writing them on this side, and then equal sign kind of is this line, and all my constants over on this side. So if I go through, this should be my x, y, and z column. Okay, so first just taking out my coefficients to my x, my y, and then my z. Coefficient here is 1, so I put a 1. Then I have 3, and then I have a -2. Equal sign again is kind of like this line, so it equals and then 5. Okay, so then if we keep going through the rest of these equations, just taking those coefficients, I have the next one as 3, 5, 6, and 7, and then 2, 4, 3, and 8. Okay, so again, you're just taking all of those coefficients out and writing them within this matrix. Okay, let's see if that marker works. Good. So the next thing then is ultimately trying to solve this. In trying to solve this, you are essentially trying to get a 0 here, here, and here. So this triangle should come down to just being 0. So I write these last two and then this one right here. So I use row operations to try to do that. So what I'm looking at first is trying to get rid of this 3. Trying to get rid of that 3, I know I have to somehow add it to a -3 to get rid of that. If I'm using my row 1, I can take 1 and multiply it by -3, because -3 plus 3 would be 0. So my first row operation will be taking -3 times row 1, adding it to row 2 to get a new row 2. Okay, I am trying to do some shortcut steps here. I want to do 2 things at once. I also know I want to get rid of my 2. And again, if that's too much for you, do this one step, then write the new matrix, and then do the next step I'm about to do. I'm going to do 2 steps in one, simply because I want to write less matrices out. I don't want to have to write this so many times. I can do these 2 steps in one because my next row operation is not dependent on what row 2 is. Okay, I'm going to simply use row 1 to somehow cancel out this row 3 first column with this x. So I have a +2, I need to get rid of that with a -2. So if I take row 1 and now multiply it by -2 and add it to row 3, I will get my new row 3. Okay, so again, there are 2 separate things. The first thing I'm going to do is take this, multiply it by -3, add it, get that new one. Then I revert back to my original row 1, multiply that by -2, add that to row 3, and again at the very end, I'll revert back to my original row 1. So no matter what, in this next matrix, I know that my row 1 will be 1, 3, -2, 5. I'm using it to give me new rows. I'm using it to manipulate the rest of this matrix, but row 1 is not changing. It's not changing whatsoever. I'm never getting a new row 1, so I know even though I'm using it, I'm not getting a new one for that one. Okay, so let's kind of work this out. We have first up using 1 and multiplying it by -3. Again, if you're okay with doing this in your head, feel free to. Just know I will not be able to correct your work very well if I don't see your work along with this. Okay, so first one, 1 times -3, -3, 3 times -3, -9, -2 times -3, 6, 5, -3, -15. Okay, again, that was -3 times row 1. Now I need to add it to row 2. Row 2 is 3, 5, 6, and 7. Add those straight down. These cancel to be 0. -9 plus 5 is -4. 6 plus 6, 12. -15 plus 7 is -8. Okay, and again, that was my new row 2. So we can write that in, 0, -4, 12, -8. Okay, and now I can go through and do my second row operation, which was taking -2 times row 1. So I'm gonna write that off to the other side now. -2 times row 1, 1 times -2, -2, -2 times 3, -6, -2 times -2, 4, -2 times 5. I was getting myself messed up there a little bit. -10. Okay, so that was multiplying row 1 by -2. Now I'm adding it to row 3. So my row 3 pops up here to be 2, 4, 3, and 8. Add those up to -2 cancel to be 0. -6 plus 4, -2, 4 plus 7, sorry, 4 plus 3 is 7, and -10 plus 8 is -2. So I get 0, -2, 7, and -2. Lastly, okay, I got my first 2 zeros. That was the main first kind of point here. We want to get those first 2 zeros. Okay, sorry about that. I was really quick. Someone was coming in. All right, so back to it. So again, we have our 2 zeros, which is awesome. The last thing we need to get is that third 0 in this lovely little triangle. I need this -2 to somehow become a 0. So when I'm thinking about this, I can no longer use row 1. The reason being, if you were to add row 3 to row 1 in this circumstance right now, you would now get rid of this 0 because you would be adding 0 to 1 and you'd get a 1 back here, which we don't want. We do not want to have any, we want to get rid of zeros we've already gotten as a 0. Okay, so leave this to be a 0. So I can only work with other rows that have a 0 in that first column. So it's going to have to be 2 and 3 that I work with right now in order to get this -2 turned into a 0. I'm then thinking about, well, what number do I need to cancel out with a -2? That answer would be +2. I don't have that answer anywhere in here right now. So there's 2 different options that I could do. The first option is I look at row 2 and I see, well, this one is all divisible by 4. So if I wanted to, I could divide this the second row by 4. That would get me down to a -1 in this first, or in this second column in that row 2. But then I'd have to still multiply by something, by some number that's going to get a +2 here. That wouldn't be that hard though, okay? That's one route I could take. Again, route 1, divide by 4, multiply by number to get this number to be 2. Okay, the 2 steps there. Route 2 that I could take is simply dividing this first row by -2. If I did that, -4 divided by -2 is +2. +2, -2 will cancel each other out to be 0. So that is route 2 that I could take. The third route I could take is by instead multiplying my row 3 by something that would get me to cancel out with this 4. That could be the other thing. So the one I'm going to go with, for no reason at all, is just to go with this row 3 and multiply it by a number. I know if I take row 3 and I multiply it by -2, -2 times -2 is +4. +4, -4 will cancel. Okay, I'm going to go with the route 3 here. So I'm going to take -2 times row 3 plus row 2 to get a new row 3. Okay, that's the important part. I'm getting a new row 3. I'll let you see kind of what's going on right there. All right. For this last step, I will do it just right over here so that we can kind of keep this in a straight line. I'm trying to find one right. Really good. There it is. All right. So last matrix over here, and then it should be solved for. We're going to use row 3, and I need to multiply it by -2 first. So -2 times -2 is +4. -2 times 7 negative 14, negative 2 times negative 2 is positive 4. And again, I was adding this to my row 2 currently. So that is 0, negative 4, 12, and negative 8. Add those up, we get 0, 0, negative 2, and negative 4. Okay, so that is my new row 3. I had a better marker. Maybe this, oh, I see it. I have too many blue markers up here. All right, so my row 1 has stayed the same the entire time. 1, 3, negative 2, 5. My row 2 has not changed since this last matrix. So it is still 0, negative 4, 12, and negative 8. My new row 3 is right up top, 0, 0, negative 2, negative 4. At this point, I can finally start solving. So I could write out one whole new huge matrix, but instead, like I typically have been doing, I'm just going to take row 3 right here and divide it by something in order to solve. So you can either do that right now or once you extract it. I like to do it right now. I'm going to take row 3 times negative 1/2. Multiplying by negative 1/2 is the same thing as dividing by negative 2. So negative 2 times negative 1/2, positive 1. Negative 4 times negative 1/2 is positive 2. So this way, when I extract, I have a lot easier time just having the z value right away. Again, you could have extracted first and then done that division. So now when I bring this back out, what I have is a 1x plus 3y minus 2z equals 5. Again, because it goes x, y, z equals sign number. And then, oh, sorry, you can't see that. And then I have no x's, negative 4y plus 12 equals 12z equals negative 8. And finally, z equals 2. So now you just need to use back substitution in order to solve for y and x. So I would take my z value of 2 and put that back up into this equation to then have negative 4. I'll bring you over here so it's y. There we go. Negative 4 times y plus 12 times 2 equals negative 8. Okay, to give me negative 4y, you can just keep solving from there. Plus 24 equals negative 8. And just keep solving. Sorry about that. Okay, just keep solving. And let's see, our next step would be dividing by, or not dividing, subtracting 24 to get negative 4y equals negative 32. Dividing by negative 4 to get y equals positive 8. Okay, so y should be positive 8 there. All right, so now when I write my solution, I do not know my x, I know my y is 8, I know my z is 2. So the last thing I have to find is that x value. So by plugging in back substitution one more time, I'm going to do that right over here. Taking this equation over, I have x plus 3 times 8 minus 2 times z equals 5. And sorry, I should plug in 2 for z. Plugging in 2 for z and 8 for y, you get x plus 24 z, okay, sorry, just making sure, minus 4 equals 5. So x plus 20 equals 5, giving me, once I subtract 20, x equals negative 15. So the last piece of this puzzle is that x equals -15. That coordinate pair there would be that solution. Okay. Again, this was number 2 on your assignment from yesterday. So if you needed a little bit of help kind of getting through that one, this would be a good video to watch. If this one went awesome for you and you kind of understand this, either go back to number 1 from that homework yesterday or move on to the last one.